Yeah.
All right, like that.
I think this is powerful.
Yeah.
So, what we're going to do today is going to use your knowledge in first and second derivative. And we're going to look at rectilinear motion. All right? Now, here, if I use this duster as the starting point, all right? This is any point, relatively starting point. Rectilinear motion means I am walking or any object is moving in one direction, one dimensional. All right? So from a starting point here, all right, I could define that direction as positive. I could also define that direction as positive. I'm traveling back and forth, all right, on one line. So here, if I walk forward, if I define that as positive, I may have walked forward for about 2 meters, maybe.
That's more than 2 minutes.
And then I'll turn back, yeah, it could be. And then walk another maybe 2 meters.
Displacement
Or
0.
3 meters and go all the way up until I crash into my
Desk.
desk. All right? So I could go forward in the positive direction, which is displacement.
Yep.
All right? Walk backwards, again displacement. Where I stop is the displacement from the origin.
Yep.
All right? Here could be positive 1, positive 2,
Yep.
and then I could go back, and this is 1 meters, and all the way to minus 1 meters. All right? Now, think about that, compare that to a total distance. What I've done in terms of total distance, I would have walked 2 meters, and then back to here, that's 3 meters. I walked a total distance of 5 meters. However, the displacement is minus 1 because that's positive, back to where the origin is, and back here. All right? So you could have positive or negative displacement. Distance is the absolute value. All right? Add all the displacement together, and that will give the distance. Velocity and speed. Velocity.
Meters per second.
Velocity has direction. So this is positive velocity, and if I turn around, negative velocity. All right? And then, of course, acceleration. I could have positive acceleration, positive velocity and positive acceleration, or I could actually have positive velocity but negative acceleration. All right, I'll explain that a little bit more. So you've got to think about rectilinear motion now in terms of first and second derivative. From year 11, you should know that velocity is the first derivative of displacement. And I did mention in my class last year that acceleration is the first derivative of velocity. So you should remember if you were in my class last year. All right? So what I really want all of you to know is understand the relationship between velocity and acceleration and use it to describe whether an object is speeding up or slowing down in a given direction. You need to be able to calculate instantaneous velocity and acceleration given an object's displacement function, solve problems involving distance and speed. I said distance and speed. You need to think about when we use distance and when we use speed, and represent rectilinear motion problems involving displacement, velocity, and acceleration graphically. So like I explained just now, when I did my demonstration, rectilinear motion is defined as motion of an object, a particle or body, in the straight line path. It is always the one-dimensional. All right? Here, I've represented the rectilinear motion of this object in different sort of in different lines. However, they should all be in the same line. All right. What happened is it's really hard to draw it, so I did it this way. So what happened is, starting from here, this object has moved all the way up here, turn around and come back, and then turn around and go all the way up there, and turn around and come back to the origin, and a little bit further. That's what it means.
Yes.
So a straight line path does not necessarily mean the equation define the object's displacement, velocity, or acceleration has to be linear in nature. You're just walking a straight line. It's not linear in terms of the function, because I can keep going faster and faster and faster and faster and faster. So you can see that when I come this way, it is actually increasing, the function will be increasing. So any rectilinear motion, it could be represented by any functions. Happy with that? Let's move on. Now, this is from last year. You should know what the displacement is. You should know what the velocity is. Don't write this down. When I when I upload it, just print it and cut it and paste it on it in your book. All right? And you've got displacement, velocity. That is what we should know from last year. So displacement, position with respect to a fixed point, 0, from the origin. It could be any point, any direction, as long as you know that it's one straight line. Positive, always define the positive and negative. Assign a sign to represent a direction from O, positive or negative. It could be in positive right, negative left. All right? It could be positive going above, like if I throw this up and down. And coming down, it's below, in front or behind. So for me, facing front or facing the back. Velocity is a change of position with respect to time. Okay? It is the first derivative of the displacement. So Vt is actually dx dt. Again, a sign to represent the direction from O. V is greater than 0, which means x is increasing. V less than 0, which means x is decreasing. So for example, if I walk really fast, the displacement will be increasing, and when I walk slowly, it will be very slow, and the displacement is sort of slowing down as well. All right? And then v equals to 0 is stationary. Now, compare the distance and speed. Distance is the absolute value of distance, the quantity without any direction. And then the speed, the absolute value of the velocity, the quantity without direction again. So, if I walk from here, if I walk 1 meter in 1 second, so of course it's 1 meter per second, correct? Yeah. Right? So if I walk backwards, another meter per second is 1 meter minus 1 meters per second. Yeah. All right. Whereas if I walk here, all the way up here, 2 meters and back, if I walk the total distance of 2 meters and in 1 second, it will be 2 meters per second. All right. So think about that. So that's the average speed, the total distance traveled over a time interval. So that's the absolute value of the velocity. And then sometimes we might talk about between certain time interval from first second to the second second. So that is the total average speed is the total distance traveled over a time interval. You must know how to calculate the average velocity, which is xb minus xa over b minus a. And then the velocity at any given point in time. T equals to a is just x dash a, the first derivative of the displacement or the velocity. All right, which brings me to the first example. Can we all have a look at this example, please? The displacement of a particle, x meters, from a fixed point O at time, t seconds is given by that. Where a positive displacement denotes movement right of O and negative left. So I have defined movement right of 0 here. If this is my right, that is positive, and that way is negative, right? So now, let's work out the displacement of the particle after 1 second. That should be pretty straightforward, all right? Now, what is it doing? So, let's think about.
How do you do D?
So, oh,
The
hang on,
interval
what
of
am I
time
doing?
where it's moving forward
I just graphed
to after derivative.
So A.
Yep.
Alright, displacement
Velocity derivative.
x
Yeah.
1 equals to 2 times 1 cube minus 9, 1 square plus 12 times 1 plus 1. Alright, that should give me 6. Now, in this sort of situation, you always should give the units, which is 6 meters. Correct? Now, how do you determine the time or times when the particle is
So
at
do
rest?
you need to give direction?
Sorry?
Right? You need direction?
No, you don't, because it's positive already.
Oh,
It's,
okay.
You don't have to give the direction.
Sure,
It's
yeah.
positive, you know that it's still right.
Yep.
You don't have to give any direction. Alright, now what about B? The times when the particle is at rest. How do you work it out?
You do derivative and then when it's 0.
So the derivative. So
V of
x
t.
t. What is xt? X
V of
dash t
t.
or dx dt?
V of t.
Alright, 6t squared minus 18t plus 12. Correct? So you need to know when it is at rest is when the velocity is equal to 0. Velocity equals to 0. The velocity is equal to 0. So this is when it is at rest. So x t equals to 0.
Graph it.
6t squared minus 18t
Or you don't have
plus
to
12
actually-
equals to 0. So therefore t squared minus 3t plus 2 equals to 0.
Graph is quadratic.
Oh, so you have to do a
X.
half, right?
X minus 1 minus 2 equals to
Like
0.
you-
Oh, actually
you
not
can
x,
graph
it's t.
it, like,
My
you
fault,
just
t.
get the turning point.
Alright,
Yeah, these-
so
Do it like that.
the particle
It's positive direction as well.
Is-
Positive, right?
at rest
Oh wait.
when t equals to 1
No.
and
No.
2 seconds.
Fucked up, mate.
Is it
Alright,
At least because
t equals to 1.
when the particle's moving
And
in
t
a
equals
positive
to 2.
direction, does that mean like
So you
the
know
sign
that at 1
has
second
to be positive or the
and
sign
2
of the
seconds
velocity
it stopped.
is positive?
No, I reckon it's the velocity.
Now, how do you work out the average velocity over the third second?
The displacement would still be in
Alright.
front, but you
How
can
do you
still-
work out the
can
average
move-
velocity
you can
of-
be moving back to the origin.
So you know
Yeah,
that it
displacement
started
still
from
goes
0,
So it'd be the
and
velocity.
then you've got 1 second,
Oh, yeah,
2 seconds, and 3 seconds,
Yeah.
correct?
It's kind of
Hey,
worded really.
hey,
Yeah.
focus please. So you really want over the third second, which is this bit here.
Grady. Grady. Like,
This is what you're looking for over the third seconds. So therefore, go back to the previous page. You need to be able to use this. xb minus xa divided by b minus a.
or like after
Which means this is
Total distance, doesn't it?
work out x3
I think you have to graph it again.
and
It'll
x2.
look like that, but then you gotta go like that, plus that, plus this, plus that, plus that.
Alright?
Shrek.
If you work out x3,
Yeah.
x3 should be 2, 3 to the power of 3 minus 9, 3 to the power of 2 plus 12 times 3 plus 1. I've worked that out to be 10 meters,
Yeah.
and I work x2 out to be 5 meters.
Over the third
So
second.
therefore,
No, I don't. I didn't do that.
the
Oh.
velocity,
I did that wrong as well.
Yeah, me too. First said over the first.
average
second.
velocity
Yeah.
is x3 minus x2 divided by, actually it's average velocity, average velocity
Divide it by 1.
10 take 5. So it's 5.
divided by 1, which is 5 meters per second. Remember, always give the
Meters per
units.
second. Yeah.
Now,
I got that wrong.
Okay.
D, the interval of times for which the particle is moving in the positive direction. How do you work that out?
Graph it.
Hmm? If you don't graph it, how would you do it?
Oh, just
If you don't graph it, how would you do it?
the
Wait, is it?
You can graph it if you want to. It really doesn't matter. You can graph it, but if you haven't got a graphics calculator, if this is a calculator-free section, how
Just
would you
use
do
the
it?
roots. Just use the roots.
Roots, and it's the middle.
And you know that it's a positive. It's concave up because it's positive up.
You can do that, or what information have you got there? T equals 1, T equals 2.
Yeah, the roots.
Can
yeah.
you work out the
Turning
the
point.
roots of the the roots of the
Velocity, yeah.
velocity, so you know which one is maximum, which one is minimum. Correct? So
Yes.
I'll work out where the maximum is, where the minimum is. So in that case, part D, what I would do is I'll work out.
Oh my
Uh,
goodness.
I will work out x. Look at the acceleration.
I think
So
it
what you want
is actually.
is the interval where the
This
particles
placement.
moving. So
Yeah, I think it is.
all right.
Oh wait, never mind. Yeah, just that.
So you know you want that. So you look at these two. So let's look up the acceleration, which is the second derivative of velocity, which is therefore equals to 12p minus 18. All right. So these are the 2 points, 1 and 2. One, t1 and t2, t equals 1 second, t equals to 2 seconds. So substitute in x 1 equals to 12 minus 18, which is minus 6, which therefore this is max. So x2 is 24 minus 18, which is 6, so which is 8. So now you can see that in between those, you know if you sketch this graph, it's something like this. All right, this is 1, and that's 2. Correct? Yeah? Agree?
So he's doing this.
So therefore, you know that this time between here, this is moving in the positive direction,
Wait,
and after 2, this is moving in the positive direction
wait
as
so
well.
why
That's
can't you just graph
acceleration.
the first derivative?
What I'm saying that, what I'm telling you is you may not have this in the calculator assume section.
No, but like you can just like
You can if you want to.
no, because you know it's a positive.
Yeah,
know
you
it's
can. You
concave
can
up,
graph that.
so-
You can do that. You can graph. You can graph. Yeah, you can graph this way. Yeah, you can if you want to.
You don't. Yeah, you don't need.
You can do that.
Yeah.
But I'm showing you the secondary. That's plenty of way of doing it.
Yeah.
I'm just
Yeah.
showing you the way that I'm doing it. That's all.
Okay.
Yeah. Right. Yeah.
So I know I'm using the second derivative to
Yeah.
find that.
Okay.
It's fine if you're drawing this graph. It's absolutely no problems at all.
Yeah.
You know where it's negative, where it's positive. Because it's a U shape, you know where it crosses. That's fine as well. So you do know that, therefore, x, t. The
3 and
time
2.
is 0 to 1, and t is greater than 2. All right? So this is when it is traveling in the positive direction. It really doesn't matter. Drawing a graph is just as well as, sketching a graph is just as well as doing the second derivative test. And finally, part E. How do you actually find the
So stupid.
how do you find the total distance traveled in the first 4 seconds? So what I would do is, I'm going to work out the displacement of 4 first. So what is x for? Displacement of 4, x4 equals to 2 times 4 to the power of 3 minus 9 times 4 squared plus 12 times 4 plus 1. If I work it out correctly, it should be 31 meters. Now, how do you find the total distance?
You tell me,
For
sir.
me, what I really like to do is I like to just sketch the graph. This is the origin. Alright? After 1 second, you have already worked out, which is 6 meters. Oh, actually, it started from, no, the origin is 0, but it started from 1. Alright, this point here, 1. This is origin. So after 1 second, it is here, at 6 meters. So therefore, that is actually a distance of 5 meters. Correct? Yeah? And then at 2, I've already worked out it's 5 meters. I've gone back to here. 5 meters. So I've got 1 meter there. And then 3, I've gone all the way up to 10 meters. So from there to there, I've got another 5 meters. And then 4, I've gone all the way up to 31. And that is 20 meters. So summing all that all up, total distance
7 plus 5
is equals to 32 meters.
31.
Alright? Now, I'm showing you the last bit. This is probably the less confusing bit if you actually draw it out properly. Makes life just that much easier if you do it that way. Alright? Are you all happy with it? Yeah? Yeah? Alright. I do one button. Can you just take a picture of that, please? Yeah, photo.
Total distance.
Save me writing everything out again. Then I'll just upload that, that's all. Thank you.
So it's 5 plus.
5 plus 5 plus 1
Alright?
21
Now,
5
let's have a look at the second question.
plus 5
Plus
Here,
31
the displacement of an object moving along a straight line is given by equation below. Alright? Where displacement x is in meters and t is time in seconds. Now, by the way, when you solve all these problems, if t happens to be negative, you must always reject that. Time will never be negative. It always have to start from 0. Alright? Never ever have a negative time. So now, can you explain why this body does not change its direction of travel?
No.
Ooh, is it always positive? I don't know. I can't tell. I mean, 5 minus 8 divided by t plus 1?
Yeah.
You've got a differentiator, right?
Yes, thank you, differentiate it. And then you can be certain. Alright, if you differentiate it, you'll find something about the denominator. And here, there's a negative. You don't know. Would this number ever be greater than 5? You don't know. But let's do the derivative.
This is 8 over t plus 1 squared.
Now, the way I did it,
Yes. Go.
so part A, x equals to 5 minus 8 times t plus 1 to the power of minus 1. So therefore, the x dt equals to plus 8 t plus 1 to the power of minus 2, which is 8 to the power of t plus 1 squared. All right. You can see, therefore, the x dt is always positive. All right? T, since t is greater than equals to 0, the x dt will always be greater than 0. Yeah? Therefore, there's no change in direction. There's only a change in direction if there's a change in velocity. Alright? So therefore, there is no change in direction.
You should sub in 4.
Try something
8 over
25.
25.
Still positive.
And then B, determine the instantaneous speed
Just
of the
velocity.
body at 4 seconds. That's pretty straightforward. So part B is dx dt at t equals to 4.
Squared then.
So it's 5.
Which is 2 meters.
So
Seconds. Still
is
positive.
8 over t plus 1 squared. 8 over 4 plus 1 squared,
8 over 1.
which is 8 over 25.
Still positive. And everyone's positive, mate.
That's the second.
What? 8 over 1
So again,
not positive.
you need to be able
You're
to use your
dreaming, Gary.
differentiation.
How's it negative?
It's not negative. Where's your negative?
Can it be negative?
No, no.
No, it can't
Example
be a
1
square.
and example 2 is to get your
T has to be
brain
greater than
thinking
0.
back to what we've
Actually,
learned
no.
in
It doesn't
year
matter.
11.
Anything squared is
Anything squared will always be positive.
Anything square will always be positive.
Yeah.
Alright? But then you can keep your phone out because I'm going to get you to take pictures.
Oh,
With my-
Pardon, take
yeah.
it down. Ugh,
All right.
this is a long question.
Let's move on. Now, let's think about acceleration now. The acceleration is the rate of change of velocity with respect to time. Alright? So it is therefore the first derivative of the velocity and the second derivative of displacement. Going from displacement to velocity, you derive the displacement once. Alright? And then from velocity to acceleration, you do a first derivation of velocity, which is the second derivation of displacement. Now, what I really want you to think, if A is greater than 0, if A is greater than 0, acceleration is in positive direction, and A is less than 0, acceleration is in negative direction. Alright? Keep that in mind.
Yes.
This is the summary of that. And what I want you to think about the focus question is, does positive acceleration imply speeding up and negative acceleration implies slowing down?
Yes.
I don't know, you tell me whether is it right? Yes, yes, yes? No?
Yeah, it depends.
Yes? Okay. Now, okay.
What are you saying, man? What are you saying? Nice. It's
I want you to think about,
Yeah,
if I throw, watch, here, if I throw a dice or ball up, vertically up, alright? Now, when it's moving, what acts on it?
What?
Gravity. So,
And
going
everything.
up, let's say that is positive, alright? Going up, what happened there? It is speeding up. When I push up, it's speeding, correct?
Yeah.
Yeah? I've got a force, I'm pushing it up so it goes faster. When gravity acts on it, what happened?
Slows
It is
down.
actually going down, right? So, it is going to be a lot faster when I push it up, but gravity is pulling down, so there's acceleration is going downwards, whereas velocity is going up. So therefore, it doesn't mean that it is with the velocity going up and acceleration, gravity pulling it down, it is slowing down. When it falls, all right, what happened is at that point, the velocity is 0, and then it started falling. So here, from 0 velocity, it will go faster and faster. See that what happened is the velocity is, the acceleration is pulling down now. So this is, if this is positive, this is coming down, negative velocity and negative acceleration, you can see that it's speeding up. So, what I really want all of you to think is that when the ball is moving up, positive velocity, the gravity is acting on it, negative velocity. Therefore, it would be, this is actually slowing down. Slowing down. Alright? So this is slowing down. This is speeding up.
Oh my god.
Alright?
Nah.
So if
annoying.
the velocity is negative and the acceleration is negative, it's pulling, it's going faster, so that's speeding up. And eventually in physics you learn what is a terminal velocity. Alright, have you all done that, terminal velocity?
No.
Yes.
No.
So think about the situation. A quick summary and a quick generalization. Alright? Here,
Do you have to do math or do you just know?
You just know it.
if an object is moving in rectilinear motion such that velocity and acceleration have the same sign, the same direction, then the object is speeding up. You cannot look at the acceleration alone. You have to look at the velocity as well as the acceleration. So if they are in the opposite sign, it is slowing down. Alright? Now, I would expect you to be able to describe when you are actually looking at an object in the test to say that whether the particle is speeding up or slowing down. So here in this case, velocity and acceleration greater than zero, that means what? That means speeding up. Alright? That will be speeding up as well because it's all negative. Whereas those two will be slowing down. Yeah? Everybody happy with that? Now,
Yeah, I equals root negative.
what if, alright, this is a question for you.
That's I.
The acceleration is 0,
Bro, don't question.
but we are still traveling. What is the velocity then? What would you call the velocity? Constant velocity. So think about it, it's A if 0, that's still velocity, that's a constant velocity. Need to be able to describe that as well, constant velocity. Which brings me to example 3. Example 3, the displacement of a particle moving in a straight line from fixed point 0 at time t seconds is defined by this. Alright? I would like you to determine the expression of velocity and acceleration function of this particle. And I would like you to try this question first, and then I will discuss it in a few minutes.
I don't know how to do gate.
I'll give you some time to do that.
Turn the position. Changes in direction occur. So, negative. Oh, I don't understand the first. D.
D.
I swear I did it, but then I'm sure.
Determine the position of the particle when changes in direction occur. Alright, so. Alright.
Yeah.
Solve the velocity for 0.
That's what I did. So it's plus or minus 1, which is only 1.
What do you mean it's only 1?
Because it has to be greater than 0.
Oh, right, yeah.
So it's only 1.
Yeah, so then.
So it's at 1.
yeah,
So that's when it changes direction.
suck 1 into this.
Into X, yeah, okay. That's what I thought I was going, but then I reread the question and I was like, is that, I didn't know.
That's okay. Everyone fails sometimes.
1 take 3 plus 1 is negative 1. E. Determine the time interval when the particle is speeding up.
Alright?
Is it always, it's
Do you
speeding
agree
up
with me this one?
from 0?
A. Now,
It's T greater.
determine the initial conditions and hence describe the motion at that instant. When you are determining the initial conditions, I want you to think about t at 0. You need to work out the displacement at 0, the velocity at 0, and the acceleration at 0. Alright? And then you can describe it. So, x0, that will give me 1. Alright? So that's centimeter. And x1, that will give me 3 minus 3. 3.
What did you get as your total distance?
X0. 0 minus 3 is not 1.
How do you mental math sometimes? 1. Wait, what's
0
it?
minus 3 is minus 3 centimeter per second.
Nah, it just looks like this, right?
And x
3 meters? Or 2 meters?
equals
It
to
was 6.
0.
Wait.
Because when x is 0, it's
All right,
1.
now,
When
how are
x
you going to
is
describe
1, it's
this?
negative 1. Let's move to a negative.
Hey,
And when x is 2, it's at
here,
3.
everyone, focus please. You know the displacement is 1 centimeter.
So 1 to...
You know
so there's 1.
the
Oh, no.
velocity is minus 3
It's fine,
centimeters
it's fine.
per second.
It's fine.
You know the acceleration is 0. So how are you going to describe the motion at that
Go on,
instant?
bro.
Describe the displacement, describe the velocity. All right?
Yes.
So, to describe that, you should say that the particles is 1 centimeter, located 1 centimeter in the positive direction from from O. All right? Give
No,
the
it's
direction
66.
whether it's positive or negative.
No.
It's 1 centimeter in the
Because it's
positive
0, it's
direction
not
from
1.
O,
Yeah,
and then
it's from...
it is moving in the
Yeah.
negative direction at a constant velocity of minus 3 centimeter per second, because acceleration is 0.
That's 2 meters.
Yeah, 2 meters.
Right? Explain. Explain that the position is
Negative
in the
1.
positive direction
Negative
from the
1.
origin or
four,
from the
four.
fixed
I don't know
point.
why I have 3.
That's 1 centimeter from there. Yeah? And then
Yeah, mate.
the velocity is in the other direction, in the negative direction. And it's constant because acceleration is 0. So I want you to be able to describe that. So position is
Oh, chain rule.
dx on dt equals.
Is it 2 t take 5 times t take 2 plus t take 5 squared times
D.
Ooh. See,
Well, it changed direction when it's a root. The velocity is a root.
all right. Part C. Describe the motion. Describe the motion of particle at t equals to 2.
No, it's
Same
gonna change
thing.
to 0.
Work out x
you
2,
solve that out.
which is
No, wait.
3 centimeter.
No, I'm gonna factor
Velocity
like a normal
at
human
2
being.
is 9 centimeter per second.
Well,
And then acceleration at 2
that'd be
is
rude.
12 centimeters per second. So in this case, what you need to actually
That's right.
say is the displacement, the velocity, and listen please, because the acceleration is the same direction as the velocity, you have to say that it's speeding up.
Solve that. Divide.
All right?
Like both sides.
Mention that this is speeding up.
Bring the 1 to the other side. Square root it.
It's I. It's I.
Displacement, mention displacement, velocity,
I is root negative.
plus speeding up.
Yeah, mate.
All right, make sure that you say that.
That's fine.
So the motion, to describe the motion, where the location is, where the velocity is,
So
and
It has to be root 1.
whether it's speeding out, slowing down.
Remember, look at this.
Right.
T is greater.
So D, E, and F, can you try that,
Sub
please?
it back into that formula there to get the position. Root 1 is 1. Yes, yeah. Root 1 is 1, bro. So it's root 1 of negative 1.
It's just I. This is just negative 1. The root of negative 1.
Negative 1.
-1 times -1
What
plus
is it?
1.
After origin, right, what does that say?
Yeah.
Which one? Positive direction from the origin.
And
You
it's
can't
traveling
you go with
And
this.
traveling at a
Bro, I'm telling you how to
constant
do this
velocity.
question. You bring up I. What do you mean? I.
24 over 6.
That's 1, bro. Equals 1.
Constant velocity.
Then I equals 1 as well.
No.
What's
Wait,
24 over
this guy's saying I is equal to 1.
No, I is equal to root -1.
Yeah, but what's root of 1?
Root of 1 is 1.
Yeah. -1 is what, -1?
Because you can't root a negative number.
Why not? Who says that?
You just can't. It's just the rule. You can't root a negative number. What's 24 over 6? For God's sake? Is it 4?
Bro, what did you say? 24 over 6, it's like year 2 math.
Even I know that. It's 3.
I just said 3. It's 4.
It's 4.
Wait, are you serious?
That's 8. 8 times. 8 times
18.
3 is 24. I got it. T is equal to 4.
1. T is 1. So something into the first one.
Yeah, to get a position.
Not bad. Oh yeah. Factual. My bro is spitting factual statements.
Yeah, mate.
1.
4 take 2 is 2.
What's 1 minus 3 equals 4?
-1.
Is it?
Wait, 1 minus what?
If you find t is -1, it's not right, alright? You have to reject that.
-1, yeah.
That's what I said.
Yeah, that's what I said.
That's true, sir. That's
Nah,
true.
bro. Nah, mate.
Now, for part E, what would you do?
16 minus 26.
So you do know that here, for part D,
Yes, that's what I got.
you work out t to be 1. You have to reject t equals to -1. Therefore, x1 is -1 centimeter. It's 1 centimeter
Square root of
in the negative direction from the origin, correct?
You can't do that.
Now, can you determine when the interval when the particle is speeding up? What do you want to look at?
Root -1.
What do you think you need to find when you want to determine when the particle is speeding up? Acceleration in the same direction as the
Because you have 3i plus 5.
velocity.
Which is
So, if I work out,
But this is imaginary because you can't have this.
in this case,
It's not a space.
x t
exists.
must be in the same direction as,
So if I
This is like the
why does it
angle.
exist?
correct?
Oh,
So,
yeah,
I
no
work
idea.
out
This line
3
is for no reason.
t squared minus 3
3i, I think.
must be greater than 0.
Huh?
T must be greater than 1. And also, here,
I have 3i.
if you look at this,
Yeah,
T,
yeah, yeah.
the smallest is 0. T is always greater than 0, correct? So, to put this condition together, it has to be t greater than 1. It cannot be between 0 and 1, right? Do you agree with me? Yeah? Because it will be, between t greater than 0, it's always, the acceleration is going always positive, right? Yeah? Yeah? But whereas when t is,
because I had it to
let's say t is 0.5, this is negative.
Oh.
Correct?
Yeah.
Yeah? So therefore,
do the opposite
you've got to look at the condition.
Is it like that?
This one, t is always greater than 1, t is also greater
This is
than
the
2.
velocity.
Both of them will be in the same sign when t is greater than 1.
Bro, yeah.
Up or down?
It's just one
Right?
possible.
You know that there's a change. This is in a negative direction. Between 0 and 1, there's a negative direction. So you are going, you've got to think about that. So t, when t is greater than 1,
Mate, will we get our piece? It's right there.
the particle is speeding up.
That's tomorrow. Good luck. We drive a KFC and get a bunch of chicken.
Yeah, man. Mine was head lifted and chicken.
Bud knows how to eat chicken.
Now, F, I'm going to give you the answer. You've got to work it out yourself, all right? It's 6 centimeter. F is 6 centimeter. Work it out yourself. I'm running a bit short of time. I want to go to example 4 and 5.
Nah, he is tomorrow.
All right? Now, example 4. The displacement of a body from some point O at time t minutes is x meters. And you got the function. Determine when the acceleration of the particle
when the
is zero,
acceleration is positive.
and therefore state the displacement and velocity at the particle at the time. Now, important, provide an interpretation of your answer in context for the question. So, let's work out
When it's falling down, it slows down.
xt. Alright, can you work out the first derivative and second derivative, please?
Hey, you still got the ball example.
Yeah, if the velocity is negative, acceleration is positive, then it's slowing down.
Now I'm going to
And vice versa.
Yeah.
So they both have to be equal.
not write everything out. I'm just going to give you your x dash t and x double dash t, alright?
Boom.
In my
Done.
solution.
Big Shack, the one and only.
Alright, I need you to be able to work out yourself.
No, I get it. I get it. Wait, E. What do you get for E?
I don't know.
Oh, it's t greater than 0.
Yeah. Well, that's what it's just a question.
No, just t greater than 0.
That's what it said here.
Yeah, but if you look at the acceleration equation, it's linear. So if it's 0, if it's greater than 0, it will be positive.
Yes.
Yeah, so it's speeding up.
What?
If the acceleration is positive, it'll speed up. Yeah. So,
No, because it has to be positive with velocity.
does it?
Yeah, because otherwise it goes this way, and then it slows down. Yeah.
Oh.
Both have to be the
True.
same.
Alright.
Yeah, both positive, both negative.
Sorry, I'm going to run a little bit over time today. I want to finish this
Yeah,
lesson.
mate.
Hey, bro, I've got to eat my lunch.
Now, what I've done is I work out when the acceleration is 0, which means the second derivative of x is 0, correct? Yeah? Are you all happy with that?
Yes.
Yeah? So from there, you can know, using that, 6t equals to 24. 60 minus 24 equals to 0.
Oh,
Therefore,
sir.
t equals to 6 seconds.
T equals to 4.
Alright? 4 seconds, not 6.
Sir.
It's
Even I didn't
4.
get that wrong.
What am I doing?
No, I asked.
Thank
got it wrong
you.
the first time.
No, I didn't. I just didn't write the answer. You
It
said
is 4.
3.
I said, oh yeah.
Alright, it is 4.
Oh, yay.
4 minus 5, so it's minus 1, minus 9. Alright, x is then not 34.
Alright, pizza time.
X is then x
Big
4
pizza, small pizza, small pizza.
Ah, round one.
is therefore 4 minus 2.
I like round.
Uh,
Good shape, but
4 minus 5
Give me
squared,
nice and juicy.
which is
Yeah.
2
So you got the
meters.
freaking land.
Alright?
So
2 plus 30,
Both.
it's tripping.
which is 32 meters.
So
Alright, now,
know where that B is right.
what can you say about interpretation of the answer? So you do know that
Yeah, you don't.
this case,
Oh, I missed plus
the
three.
displacement of the particle is 32 meters in the positive direction from origin, but it is traveling at a constant
Yeah.
speed in the negative direction. Alright? So what is happening is, it is 32 meters from the origin. Let's say the origin is there.
Sometimes.
Alright?
Which
I
one?
am moving backwards. Alright? Moving backwards.
Go down.
At a constant speed because the acceleration is 0. Alright? At a constant speed because the acceleration is 0.
Yes.
Happy?
Happy.
So how did you get
Got it?
3t taken out?
Sorry?
How did you factorize it? Like, I mean, differentiate.
Using
Product.
product rule
And factorize.
and chain rule
And chain rule.
and factorize.
Product and chain rule.
Alright? I'll write it out after I finish this. Now the last one.
There's like
This is
imprinted
important.
in my head after sending.
You will be. Just give me 2 more minutes, please.
So it's mine.
I'll stop right at. I'll stop right at
Is that right?
11 o'clock. This one is an interesting one
Is that right?
because what you need to think about is this point.
I possibly got it wrong.
No, you're wrong.
Alright?
I'm wrong.
I want you all to think about this point.
Isn't there like thousands of answers here?
Yeah. There's like
I want you all to think about this point.
9 to 7.
Focus, please, everyone.
Inflection point.
Hey, what happened
Could be 10.
when the acceleration is 0?
POI.
Stationary point. So stationary point, where could this be?
Anywhere, up or down.
Well,
Either
could it be
graph.
here?
Could be either graph.
Yeah?
No.
That's what you did, bro.
Could it be here?
No.
Yes.
Or I'm going to use a different color.
It could be anywhere.
Could it be
because
here?
We don't know plus sync.
Now,
Okay, give me mine. I got that.
all right, please. Focus, please. Here, it makes a difference if this point is on the axis or not on the axis. Because if both of them are 0, what does it mean?
Horizontal point of inflection.
It's horizontal point of inflection.
Yeah.
If not, it's oblique point of inflection. So that point here actually affects the graph there. All right. So what I'm going to do is draw the graph to show you if it is below and above. So it's below, it could be something like this. Could be something like this,
Yep, that's what I
or
did.
something like this. All right. Now, the graph in that case will then be, there is a horizontal point of inflection. So here, from here, there should be a
Point of inflection.
maximum or minimum, maximum. So it's positive. All right. This bit here, I'm going to use this graph. So it's positive. The slope is positive. And then positive again. There's another one, positive again. Positive. Hang on. I'm doing it all right.
Enough, yeah.
Hang on. I'll just do this one. So from there, what you will get is something that way. And going up. Oh no, not right. It's very hard to draw from here. It's here, something like this.
Yeah.
Oblique point of oblique point, and then all the way up. Hit
Nah,
there.
it's close enough, sir.
And no, hang on.
Sir, I've got it. Don't worry.
It's not right. So I've got to go down and then up, something like this. Whereas if it is that point there, what you will get is this. All right, it will be something like this, the purple line. All right. So see the difference between those two. All right, I'm going to stop here.
Can't be right.
So it's not right because at the start it's positive gradient, but it's negative.
Hang on.
Because at the start it's positive gradient.
Negative
So negative gradient, but then it's positive.
Negative. So something's wrong. I've done it incorrectly.
Yeah, it's okay.
Yeah, that's fine. I've done it. I'll do it again. All right. Baden, can you forward the thing to me, please? The two photos to me, please. Thanks.